quadratic equations are often presented in standard form. In standard form, a, b, and c just represent constants. It is in our interest to find solutions to these equations, or when these equations are equal to 0. The issue with the standard form quadratic is that we cannot just directly solve for x, because I have a term that we refer to as the quadratic term with an x squared and a linear term with just an x. And those are not like terms and therefore cannot be combined. So isolating x in its current format cannot be done. What we did show is that through completing the square, we were able to reformat our standard form equations that would allow us to directly solve for x. So completing the square is a solution that we can be using at any time. However, there are issues with completing the square when certain numbers are presented in our A, B, and C slots. And we found out that it's often not the most efficient way in certain scenarios. So is there another method that we can use to solve a quadratic at any time? And the answer is yes, and that's called the quadratic formula. In this video, we'll focus on the derivation of the quadratic formula. To get the quadratic formula, we take our standard form equation and we set it equal to 0. Knowing that completing the square is a valid method to solve any standard form equation, we are going to do that on this standard form with A, B, and C still present. Our first step in completing the square is separating our constant and our variable terms. Then, we want a leading coefficient for our quadratic term to be a positive 1. Right now it is a, so we're going to divide both sides by a. After that is done, we will have the following. We are now ready to complete the square. To complete the square, you will take the current b term, which is b over a, divide it by 2, and then square it. And then once you've done that, you add that quantity to both sides. So off to the side, our current b term is now b over a, and if we divide it by 2, and then square it, what do we get there? Well, dividing by 2 is the same thing as multiplying by 1/2. And in general, dividing by anything and multiplying by reciprocals are the same operation. So if I divide by 2, that is the same as multiplying by 1/2. And I can clean this up so that it looks like the following. And that is what we are going to add to both sides. And in fact, let's just actually square it. So we'll get b squared over 4a squared. So we're going to add b squared over 4a squared to both sides. And that will be our completing the square process. Now that we've successfully completed the square, on the left side, we have the perfect square trinomial that we are always looking for in the completing the square process. We already know that when we factor this, we're going to get the same thing twice. So we're going to do the shortcut here because the way this perfect square trinomial is presented, it's not very nice to deal with when we have that b over a and b squared over 4a squared notation. So the shortcut, we just do x, and then the number that's going to be inside that parenthesis through the factorization will be whatever b over 2 is. And we already found out what b over 2 is. It equals b over 2a. So we're just going to add b over 2a. Then equals, and what we have on this right side, we can actually combine, so let's do that right now, into one ratio, so one fraction. To do that, we need common denominators. So right now, we have negative c over a, and we have plus b squared over 4a squared. If I want to combine this, we need to have 4a squared as the denominator for both. On the left, we just have an a. How do I get from a to 4a squared? Well, I would have to multiply the bottom by 4a. If I multiply the bottom by 4a, I have to multiply the top by 4a. So that idea is multiplying by 1. Because I'm multiplying by something divided by itself, which equals 1. And multiplying by 1 will not change the value, but rather just change how it looks. And when I clean that up, we're going to get negative 4ac over 4a squared plus b squared over 4a squared. So now that these have common denominators, I can combine them into one ratio. And I'm just going to change the format, or the order of the numerator, I should say, into the following. At this point in the derivation of the quadratic formula, I have reformatted the standard form equation so that now I can solve directly for x using just inverse operations. So to isolate x on the left side, I first have to get rid of that squared exponent of 2. And I can do that by taking the square root of both sides. When I take the square root of the left side, we get the cancellation because of the inverse operation. And on the right side, remember the plus minus out in front when taking the square root of both sides. And lastly, I can move the b over 2a through subtraction. What we have done is successfully solve for x when presented with the standard form equation for a quadratic. And you'll notice on the right side that what I have here is just something that is in terms of a, b, and c, meaning if I can successfully identify a, b, and c in the standard form quadratic and just substitute those values into their respective locations, when I clean that up or simplify it, it will tell me what x equals. This is not the quadratic formula that you will be presented with. So we can take this a few steps further by just cleaning up some of the arithmetic within this problem. In the square root, you'll notice that the denominator 4a squared is actually a perfect square. So we're able to take the square root of that. And I can split up this square root with my radical properties, take the square root of the bottom, and the square root of 4a squared is the square root of 4, which is 2, and the square root of a squared, which is a, so for 2a. Now the convenience of that is that now I have two things with 2a as their denominator, so I can combine these two things into one ratio and get the following final result, where I have negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, if I can get the values of a, b, and c from my standard form quadratic and just substitute them into these locations, simplify it, I will be able to find the solutions to the quadratic equation. And this is the quadratic formula. So we will write this in our final presentation of the quadratic formula is a formula that can be used at any time to solve quadratic equations. And it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, a, b, and c are just the constants in a standard form quadratic. So identify a, b, and c, plug them in, they're your solutions. And that is the derivation of the quadratic formula.